Welcome back, guys. Today we're doing January 2019 CSEC question number 10. Three matrices are given as follows. Matrix P, -1, 2, 0, 5. This is a 2 by 2 matrix. How do I know it's a 2 by 2 matrix? We have one row and then another row. So that's two rows. This is one column and another column. So this makes it two columns. So this matrix is a 2 by 2 matrix. So we have two rows and two columns. This is a 2 by 1 matrix, one row, two row. Then we have one column. So that's why we're able to say we have two rows and one column. So this is one row, two row, and one column. Just remember, one row, two row, and one column. So that makes it a 2 by 1. And this will be the same order, which is a 2 by 1. The first part says, using a calculation to support your answer, explain whether matrix P is singular or non-singular matrix. Now, a singular matrix is where the determinant of the matrix is 0, while a non-singular matrix, it is when the determinant is a value other than 0. So if I have P, which is -1, 2, 0, and 5, to find the determinant of this, I'll multiply -1 times 5, minus 0 times 2. So the determinant of P, I will have -1 times 5, that's -5, and 0 times 2 is 0. So calculating the determinant, it is -5. Now, having a value means that this is a non-singular matrix, because a non-singular matrix, the determinant is not 0. If we got the determinant to be 0, then we will say it is a singular matrix. The next part says, given P, Q, and R, determine the value of A and B. So P is -1, 2, 0, and 5. Q is A and B, and R is 11 and 15. Just a reminder, I got it from here. This is the information that was given to me. Now, for the first matrix, this is a 2 by 2 matrix. Remember, I had mentioned the order before, while this is a 2 by 1. Having it in this order, it shows that it is defined. When the rows and the columns are the same, it is defined, and this is what tells me I can go ahead and multiply, and the outside tells me the order that I will get after multiplication. When multiplying, I'm going to multiply row by column. So we are going to divide the first matrix into two rows. So multiplying this, row by column, -1 times A, that's -A, plus 2 times B, that's 2B, row by column, so 0 times A, that's 0, then 5 times B, that's 5B, so I'll have plus 5B. It's equal to 11 and 15. Now, when we have these being equal, we're saying that when I find out what is the value of A and B, it should calculate to give me 11. And when I calculate this 0 plus 5B, whatever is B, it should give me 15. It's just as if I have two matrices. 3, 2 is equal to 3, 2, we're saying the positions are exactly the same. That's why we say equal, because the positions are the same. So that's the same concept here, is that when we find out what is A and B, substituting it, I have to get this to calculate to give me 11 and this to calculate to give me 15, because of what is given, that the left hand matrix is the same as the right hand matrix. So in other words, I'm going to equate the positions to be equal. So I have minus A plus 2B is equal to 11. And then I have 5B is equal to 15. Now, in reality, some persons are able to find out what is B just by looking. But here I'm going to divide both sides by 5. So B is equal to 3. And now that we know what is B, we can go ahead and find out what is A. So substituting what is B, I will have 2 times 3 is equal to 11. So minus A plus 6 is equal to 11. Then we carry the 6 over the equal sign. So I have minus A is equal to 11, take away 6. So I have minus A is equal to 11 minus 6, that is 5. And minus A is the same thing as rewriting this as negative 1A. So the coefficient is negative 1, so we divide both sides by negative 1. The negative 1's cancel, and A is equal to minus 5. So here we have A to be negative 5 and B to be 3. So we can always test it. Substituting minus A here, we have minus A. So A was negative 5, so the negative and negative would be positive 5. And replace B to be 3, so 3 times 2 is 6. And 5 plus 6 will give me 11. And same case here, replacing B with 3, 3, 5 will give us the 15. So that's how you test your answer. Now, the next part states the reason why the matrix QP is not possible. Matrix Q is the one with A and B. We just calculate that A is negative 5 and B is 3. So Q is negative 5 and B is 3. So for Q, I will have negative 5 and 3. This represents matrix Q. And for matrix P, I will have minus 1, 2, 0, and 5. When we're multiplying, we have to check the order. So the order for Q is 2 by 1, 2 rows and 1 column, while for P, it is 2 by 2. So the explanation is that it is not defined because the row and the column within is not the same. In order for us to multiply, it has to be the same. Remember when I was multiplying this, I check if it's able to be multiplied, where the order to find out if the row and the column, they are the same, and they are the same, so this tells me I can move on to multiplying this. So in this case, it can't be multiplied. That's not possible. Now, the next question, we're given OA, BC is a parallelogram. X is the midpoint of AB and Y is the midpoint of BC. OA is R and OC is S. Complete the diagram below to represent all the information given above. OA is R, and I'm not seeing any OC, but we can have that. We're given that the parallelogram is labeled as follows: OABC. So following that order, we'll have OA, then this will be B, and here we'll have C. So the order, based on what is given, OA, B, C. For a parallelogram, we know that the sides, these two sides are the same and they're parallel. and these two sides are the same and they are parallel. We also know that x is at the midpoint of AB, so this is x, while y is the midpoint of BC. So we can go ahead and create position vectors OX, and the next position vector will be OY. And we were given that OC is equal to S. Now, part 2 says, given that OX plus OY is equal to KR plus S, where K is a constant, using a vector method, find the value of K. OX and OY needs to be found, and what we can do, we can use the information that we have here. Now, what do I have? I know that OC and OA are parallel and the same size, so AB is equal to OC. So OC is S, so that means that AB is also S units. But that also tells me that AX is a half S, and it's a half S because this cuts the line, the line at the center. So AB is cut at the center here. And if AB is S units, then it means from A to X must be a half, exactly a half, because this is at the center. Having this, we're able to find OX because we have what is OA and we know what is AX. So OX is equal to OA plus AX. But let me do this on this page. So we know that OS is equal to S. So it means that AB is also S. Since we have that information, then if I need to know what is OX, then I can use vector method where OX is equal to OA plus AX. Now, for OX, we know that, remember, you know, OX is equal to OA plus AX. OA is R units and AX is a half S. So I will have OA being R and AX being a half S. We now need to find out what is OY. So to find out what is OY, we know that OA is equal to BC. So if this is R, then it means BC is also R. They are the same size, so that is why we're able to say if this is OA is R, then BC is also, CB is also R. So writing this information down, OA is R, but OA is equal to CB. So since they're equal, then it means that CB is also R. Now Y cuts the center, so it means this CY will be a half R. To find out what is OY, OY is equal to OC plus CY. So OY is equal to OC plus CY. Now OC is S, so I'm going to replace it with S. And CY is a half R, because Y is at the center, so from C to Y is a half R. No. Where I have S is equal to a half R, that represents OY. And where I have R plus half S, that represents OX. So what do I need to do now? I need to use the information that is given to me. So OX is equal to R plus a half S, and OY is equal to S plus a half R, right? So this represents OX and this represents OY. This part now, I will have K open brackets R plus S. So replace OX with this part and OY with this part. Now simplifying, we're going to group like terms. So I'm going to have R plus half R, and then I have a half S plus S is equal to K open bracket R plus S. R is the same thing as 1R, and S is the same thing as 1S, and I'm going to put it in a different color so that you know that it's not a 15 but a S. When we're adding, we add 1 plus a half, and that will give us 1.5. So 1 plus a half is 1.5 R. And here is the same thing, half plus 1, that's 1.5. So I'll have plus 1.5 S is equal to K open bracket R plus S. Now before I go further, let me just explain further with the fraction. So if I have a half plus 1, that will give us 1.5, or some persons would say 3/2. If you're not sure with this, you can just put a half plus 1, and you put 1/1. Find the LCM, that's 2. Then 2 into 2 goes 1 times 1 times 1, that's 1. Plus 1 into 2 goes 2 times. So 2 times 1, that gives me 2. So here I have 1 plus 2, that's 3/2. And 3/2 is the same thing as 1.5. So when you're doing algebra, if I have 3R plus 2R, we add the number 3 plus 2, that gives us 5, then rewrite the R. If I say 6R plus 2R, I will add the 6 plus 2, that gives me 8, then I rewrite the R. So it's the same concept here, where I add the 1 plus a half, that gives me 1.5 R. Half plus 1, that gives me 1.5 S. No. Look, I'm going to put this in brackets. 1.5 is common, so I can factor out 1.5. So factoring out 1.5, this is common. There's no longer 1.5 here or here. So all we're left with is R plus S is equal to K open bracket R plus S. So for this, I have 1.5 R plus S is equal to K open bracket R plus S. These are the same in terms of I factor out the 1.5. When I factor out means you take out what's common. If I took out this, I'm left with just an R. That's why I have an R here. And I factor out this. That's why there's no 1.5 here. Just a reminder, if anybody forgetting, if I have 2x plus 2y, and I say factor out the 2, it means I factor out the 2 here, and I remove it within, so I have x plus y. If you need more practice with factorization, you can revisit my video where we factorize. So we factor 1.5. Now remember, when we have an equal sign, it means they are similar. So the brackets are the same. So here I have this to be k, where k is a constant, so it means k is the same as this value. So automatically, k is equal to 1.5. So once again, I have ox plus oy is equal to k r plus s. OX has been replaced with what I have here. That's what I have. And OY is in this position. Then we group like terms. So I have R plus a half R and a half S plus S. R is the same thing as 1R. S is the same thing as 1S. So we can add 1 plus a half. That's 1.5. Then we rewrite the R. Half plus 1. That's 1.5. Then we have S. Now 1.5 is common, so we can factor out the 1.5 and we're left with R plus S. So these are the same. So we can say the number that's in front is the value of k, because once I replace k to be 1.5, they look exactly the same, and that's what the equal sign means. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have more questions, you can leave a comment below. Have a great day.